Welcome back. Now let's discuss about approximation and percentage error. As we know, we can find error in approximation or measurement, or we say we find error in measuring instrument. In this lesson, we'll be discussing approximation as error in approximation. So let's get to it. We have that error in approximation mathematically is given as 1/2 times the smallest value of the approximation. The question here is, how do we obtain the smallest value of any given approximation? Let's take a look at it. The first one, if we are given an approximation using the decimal places, that is, digit after the decimal. If a number is rounded up to one decimal place, then the smallest value of such approximation is 0.1. For two decimal places, the smallest value is 0.01. And for three decimal places, the smallest value is 0.001. Well, suppose we have approximation given using significant figure. Depends on the digit given, though the smallest value varies based on the type of numbers given. If we have 6,400, for example, to one significant figure, that means we are rounding on the first digit. If the digit, of course, is not starting from 0. So the position of the value is what we use to get the smallest value. How? If you look at the position of 6 in this number, the position of 6 is 1,000. That's 6,000. So the smallest value of that position is 1,000. That's what we use as our smallest value of the approximation. But if the number is rounded off to two significant figures, the second significant figure here is this digit 4. And the position of 4 here is 400. So the smallest value of the approximation is 100. And if the number is rounded up to three significant figures, the fourth significant figure here is 0. So we say the smallest value of that position, because this 0 is in the position of tens. This is unit, this is tens. So we say the smallest value is 10. So if we have a decimal number like this, 0.0736, taking it to one significant figure, as we know, 0 here is not significant, it's not significant. Then the first significant figure here is 7. So the position of 7 here is 100. This is tenths, this is 100. So the smallest value of that position is 7, or say 100. That's 1/100. So we write it as 0.01. While to two significant figures, we should be rounding up this 3. That's 1,000th position. So the smallest value for that approximation will be 1,000, or 0.001. If we have approximation given to the nearest unit, say to the nearest centimeter, to the nearest kilometer, then the smallest value of such approximation is going to be 1. It's going to be 1. That's what we use when we are trying to calculate the error in that approximation. Let's take a look at this. Let's learn them. You can watch this video over and over again until you get it right. In the next lesson, we shall be solving some examples. See you on the next one.